This is Algebra 1, Lesson 29, Practice. We're going to be doing problems using negative exponents and zero exponents. Problem A tells us that we need to simplify that, okay? So we're going to want to get the 2 out of that denominator, so we'll bring it out, which means we have to change this to the opposite sign. So that's going to be equal to 2 to the third. 2 to the third is 2 times 2 times 2. So that is just equal to 8. B, the whole base is negative 4. Okay, so I can write that as a fraction. I'm going to move it to the denominator, okay, so that I can change the sign of the exponent. So it'll become positive 2. So what we're trying to do, get rid of that negative exponent. So if the negative exponent was in the fraction, bring it out. If the negative exponent was in not a fraction, we'll take it to a fraction. Whatever we got to do to get it to where it's a positive exponent that we can deal with. So this would be equal to 1 over negative 4 times negative 4, which is positive 16. So B is the 1/16. C. All right, we've got here a fraction, but then we've also got, well, actually, this would be easier. Let's take it out of the denominator, okay? So that's going to be negative 3, and its exponent would change to a positive 2. Now, the parentheses were there, so that means it's part of the base, so negative 3 times negative 3 would be a positive 9. So the answer to C is positive 9. Anything to the 0 is equal to 1, unless that number were 0, which has no value, remember. Here, what's your base? This had a base of 8 to the 0. This also has a base of 8. This is not negative 8 to the 0. This is the opposite of 8 to the 0. You got to think about it that way. 8 to the 0 is a 1, and then you take the opposite, which is negative 1. This causes a lot of errors in algebra, so be careful with these. The whole negative 3 is the base, and that's raised to the 0, so that's a 1. G, that one looks rough, doesn't it? Until you notice something. What do you notice? The whole base is being raised to the 0. So guess what this whole thing is equal to? 1. The whole value is equal to 1. You hope there are lots of those in homework, right? All right, H. We can look at these and say, I know I need to have the x with this x with this x. So I've got a negative 3 plus a 4, which is a positive 1. That positive 1 plus the 2 is a positive 3. Okay, now I'm going to do the y's. Here's a y. Here's a y. So we're going to do negative 8 plus the 5. So that's y to the negative 3. Now let's deal with the z. Got a z here and a z here. What's the exponent with that z? It's a 1. So that's going to be z to the 1 plus 5, which is 6. So that is our final answer here. I. We've got an x to the 6th and an x squared. So that's x to the 8th. Then we've got a y and a y. That's a y to the negative 3 plus 3, which is a y to the 0. But we know that y to the 0 is just equal to 1. So that's just going to be equal to x to the 8th. Use the distributive property to expand this. Let's see if there's anything we can simplify. I don't think so. I don't see anything to the 0. So we have this factor on the outside times this term times this term. So let's start out here with this factor times this term. We have a number, so that's a coefficient of 2. We're going to do this x to the negative 2 times x to the positive 2. okay? So that's going to be x to the 0, right? We'll deal with it in a minute. Y cubed times y. We know that this y has an exponent of 1, right? So that's y cubed times y to the first, so that's going to be y to the fourth. Now let's simplify that a little bit. We know that this is just 2 times 1 times y to the fourth. So wouldn't it be much easier to just say that's 2y to the fourth? I think that's a lot simpler, isn't it? So now what we're going to do is we're going to go back. I'm going to erase my markings here. And we're going to do this factor times this term. Okay, so we're going to have this 2 times this minus 3, a negative 3. So that's going to be a minus 6, or a plus a negative 6. Here I've got an x to the negative 2 and an x to the negative 1. That's going to be x to the negative 3. Here I've got a y cubed and a y to the negative 3. That's going to be y to the 0. Let's simplify this a little bit. Still going to have these, but that y to the 0, isn't that just 1? So I'm multiplying this term by 1, so it's just going to be this term. And that will be your final answer to this problem.